you're enjoying the MOOC so far. I'm Helen, one of the mentors helping out, and I'm doing my PhD on Southern Ocean circulation, looking in this area here.
Hello, I'm Cristian, another of your mentors, and my PhD is looking at freshwater, Arctic freshwater, and circulation in the Labrador Sea, which is more or less here. We decided we also wanted to go through the fun of running this experiment, and we're demonstrating them for you.
Fingers crossed we can get it right.
Hopefully we will. I hope you enjoy them. So if we wait a little bit, we can see that in this case, the melting water is fresh and cold, and it will sink because it's denser than the environmental water, which is warm and fresh. But on the other case, we can see that the fresh water melting is staying on top, because even though cold water is denser than warm water, the environment water is salty, and that makes it very dense as well. So in this case, density is controlled by density, and our fresh water, resulting from the melt of the ice, is staying on the top. You can see how the melting water is making these little chimneys, and it's moving, it's sinking to the bottom. And those processes, we can see them, for example, in the Labrador Sea, where we get really cool water and very salty, and it's very dense, therefore it sinks in these convective tunnels.
Analog to this that you might find yourself experiencing is when you go snorkeling and it rains, and you'll find yourself in a cold freshwater lens with the warmer water below you in the salty sea as the fresh rainwater sits on top of the salty seawater.
So we are running now experiment 3. What we have here is our environment water, which is warm and fresh, therefore will be very light. So Helen will add some warm and salty water that has some food coloring, some food type, on the side of the tank, and we will see what it happens. So what we can see is that the water we are adding is denser, therefore it's sinking, and it's sinking through this sort of convective chimneys, which they have this characteristic shape. So the water we are adding is then sinking to the bottom. So what's happening to the other water, the warm and fresh water? It's lighter, therefore it's being lifted up, it's moving. So we're generating this sort of convective cells where, as water sinking, some of the water is replacing that water.
Okay, so where this becomes really important is where you have regions of the world where ice forms on the surface. So this is our ocean basin. As the temperature starts to drop, ice will start to form floating on the surface of the ocean. And what happens is that only the freshwater component forms ice. So as all of the fresh water crystallises out and forms ice, all of this salt forms these cascades in a process that we call brine rejection. So we have this sinking of heavy, dense, salty water, which is very cold, and when it starts to form this deep water, which is really important for how global thermohaline circulation works. And this water then moves away in key areas of the world, and it helps to maintain the draw of warm water in the Gulf of Mexico, which helps to keep us nice and warm. So as it sinks and it moves away, it sucks more water down in turn, and we have circulation starting. This happens in several key areas of the world, notably in the Nordic seas and off of the south tip of Greenland, and that's part of my ongoing research work. So this is experiment number 4. And what we're doing is very slowly pouring our nice, fresh, warm water on top of a layer of salty water. This was taken from just outside, so this is proper seawater, but you might need to make it quite salty for the experiment to work. You need to pour it onto something that floats, so we've actually taped together some ear defenders to form a small raft, so you're not making too many splashes. And Cristian is going to add enough so that we have a nice distinct blue layer on top of our salty seawater.
Essentially what we've ended up here is what we had and saw in experiment 1 with our freshwater lens sitting on top of our salty water. So we've got fresh, less dense water sitting on top of salty, dense water. And
now what we will do is add some more water with another color, and this time it will be cold and salty, very salty, so it will be very dense, and we will see what happens.
not salty enough.
Yeah.
You can see here that we've been adding our red salty water, and the expected plan was that as we added it, it would be denser than the salt water that's clear, and it would sink down to the bottom, and we'd have a nice distinct red layer down at the bottom. But this is an exercise in not measuring your salt content properly, and effectively what we've done is prove that our red salty layer is less dense than our salt layer at the bottom. So that's why when we inject it down, it's basically sitting between our seawater layer and our freshwater layer on the surface. So you should be able to see that we've got a distinct purplish layer now between our two horizons. So if you've used very salty water to produce your final layer, then it will sink down to the bottom. But if it's less salty than your seawater layer, it's going to sit somewhere in the middle. So we can...
Well, I hope you guys enjoyed that. Hopefully you saw some of the key concepts we've been going over in the paperwork beforehand. As you can see, sometimes it doesn't go to plan, but I guess that's science really, isn't it?
This is true. If you do have any questions about the experiments we've run today or anything else on the MOOC, don't forget you can join us on Thursday at 1 o'clock UK time for our first Google Hangout, where we're going to be joined by a few other scientists from NOC. It should be great. You can tweet us a question at UOS Oceans or leave us a question on the blog, and we will get back to you. Look forward to seeing you there.